Well, hello, John. Hello, Todd. It's another episode of Flight Safety Detectives. Good to see you guys, as always. Again, I've been a traveling maniac. Finally just got back from Connecticut, working an accident there. And I know that you guys are snug as a bug in a rug somewhere in these United States.
And loving every minute of it.
Yeah, I too have been on the road. I've been up and down the East Coast repeatedly, dealing with some airport issues and also dealing with some corporate flying issues and safety stand-downs. So I too have been busy. I'm on the road until it looks like October 12th or 13th.
I'm sure
I am looking forward to going home. My life has changed after the pandemic because I got used to staying home for a while. So it's been a big change from being on the road virtually 46 or 48 weeks a year, now slowing it down. And I'm liking it getting home every once in a while.
Well, I know your parole officer is happy to hear that you're actually working.
Yeah. I'm sure of that.
And how about you, Todd? Where are you hiding?
Well, hiding here in Boston still. And unlike John, who's like boldly going now that the pandemic is winding down, I'm a little bit more of a, wait and see attitude kind of guy. But I can't wait to get back on the road myself.
Yeah, well, you had a little event. We're recording this show, of course, but there was an event at Boston Logan recently involving an Allegiant. I think it was an A320, blew a tire on landing, went off side of the runway at Boston Logan. So we'll find out what's going on with that, why they lost the airplane so bad with a blown tire, and probably talk about that in a future show. But today I think we're going to have a very good show. We're going to be dissecting a general aviation accident involving 7 fatalities, unfortunately, all from the same family. It was a Cessna 421 that had experienced an in-flight engine issue, especially in the area of weather as well. And so we're going to be dissecting that, and that's going to take up the bulk of this show. So before we actually get into to looking at this accident, I want to thank, of course, Avemco and PAMA, and John, you're our spokesman for those sponsors. So it's all yours.
Okay, so I want to remind everybody that this show today is brought to you by PAMA, the Professional Aviation Association, Maintenance Mechanic Association. And if you have any questions or you want to look them up, PAMA.org, PAMA.org will get you there. And Avemco is a general aviation insurance company, and they insure all sorts of general aviation, from hull loss to CFIs, to if you're going to rent an airplane, anything involving general aviation, they're your insurance person that you should talk to. And if you mention the show, you're going to get a 5% discount on top of anything else that they have to offer for you. And I can tell you, after spending several days with the Avemco folks at Oshkosh, I was thoroughly impressed with their knowledge and their ability to speak pilot language, even though several of them were not pilots. And they're very, very knowledgeable. And they will talk to anybody, whether they have your insurance or not. So give them a call. You're not under any obligation. Give them a call and see what they can offer you. I know they're very flexible because they insure one of the other 3 people on this broadcast, and we know that might be very risky.
Yep. I know paybacks. I missed one
trying
show.
To get ahead today. I'm trying to get 1 in before I get 5 in return.
Yep. See, everybody's always sending us emails going, man, Greg, you're so hard on John all the time. You're so hard on John. I know you're trying to get your shots in. Well, like I've always said, paybacks are hell. So just when you least expect it.
And before we get into it, I did not take my flying lessons from Orville or Wilbur.
Yeah, was the guy's name Blériot or something? Wasn't he French?
Okay.
Yeah, keep going.
Yeah.
I'm ready, man. I got the whole book of comebacks, John.
I'm sure. Well, I'm looking forward to today because we're going to talk about an investigation that the NTSB concluded, and they reached a probable cause that satisfied their needs, but it wasn't as detailed as it needed to be. And we're going to dig into much more detail than they had the time or resources to get into. And, you know, we collectively, we lament often the fact that the NTSB report, to give it a once over lightly, is the most obvious cause. It's not always 100% true, but it is not deep enough to satisfy a lot of us. And you need to dig deeper. Now, and it's a question of manpower and resources on the part of the NTSB. If they did every accident like they do the major accidents, they just don't. They need 10 or 15 times the money of the people to do all of that. But I have long felt that the general aviation community has received the wrong end of the stick for a lot of the accidents. And I wish the NTSB would take a percentage of the general aviation accidents and do an in-depth analysis, not just what they have been doing over and over and over. Yeah, and while I was there, I pushed and tried to get that done. I failed. You know, people don't realize how hard it is sometimes to push on the bureaucracy and push on the system. And even though I was on the inside, I failed. If I push really hard, I got one accident to be elevated, but they quickly went back to the business as usual. It's so be
well,
that
John,
as it may.
But I have to disagree that, you know, the board owes it to the public to do a thorough and methodical investigation on every accident. And for them to try and meet a 12-month window, an 18-month window, a 24-month window, that doesn't matter. They have to get to the root cause. And this is a perfect accident, a general aviation accident that should have been thoroughly investigated. My responsibility as an investigator when I was out in the field as a field investigator was to do thorough and methodical investigations. Okay, if it took 13 months, it took 13 months. If it took 2 years, it took 2 years. But if I got to the bottom line, then that was the accomplishment of my hard work on behalf of the NTSB, because in order to promote and enhance aviation safety, you cannot do it through obvious cause. You cannot do it through not vetting the information that we're going to talk about in this report. And as you and I have always talked about on this show, and that's really the premise of this show, it's the backstory. And I know this accident very well because I had some involvement in it after the NTSB's investigation. And it just pains me when they don't do thorough and methodical. They put a lot of filler in this report. It looks really good and real thorough, but it's just factual filler with information that isn't really important to the bottom line. And we're going to get into that. But they have the resources. They aren't doing the accident numbers that when I first went to the NTSB, and we were doing almost 4,000 accidents a year, and now they're doing maybe 1,500 to 1,800. I can't buy that as an excuse, John. They have a purpose and a mission, and you have 40 plus investigators sitting out there at home, working out of their homes, who get launched on these accidents. They owe it to the flying public, especially the general aviation public, not only to do thorough and methodical, but to enhance aviation safety. And I think this is just a perfect example of where they failed in that mission.
Well, one area that we both can agree is that we both like to see, to use your words, thorough and methodical investigations right to the real conclusion. And all the stuff before that, we can agree to disagree on.
Yeah.
So with that, let's get into it because I believe this is a good one to highlight that more work on the part of the NTSB was warranted.
Yeah, I mean, this, it was a sad accident. It was a 7 fatal accident. Pilot, his wife, and 5 of their kids, varying ages, were flying back from an airport just outside of St. Louis back to Destin, Florida. Cessna 421C model, very capable airplane, equipped with 2 IO-520 Continental engines. Everything, according to the witness, who happened to be the pilot's father-in-law, they knew that they had taken off that morning, earlier in the day, about 3:30 in the afternoon, to head back to Destin, Florida. The initial parts of the flight, the pilot had gotten weather briefing, filed an IFR flight plan, was up at 21,000 feet. Direct to Destin, Florida. And en route, there was weather, and weather had been forecast, and the pilot was made aware through air traffic control communication of convective segments along his particular route of flight. He acknowledged those segments. They were given even a high WAS frequency to find out more information about the convective activity. As the airplane progressed, and was in the area of Alabama, the pilot did run across and was deviating, told air traffic control that he was deviating around some convective thunderstorm type activity. He was reporting some turbulence and had been given permission by air traffic control for these deviations. The airplane was still at 21,000 feet. We've got the airplane on radar. He's tracking. It's apparent the airplane's tracking on autopilot. The Cessna 421 that he was flying had been modified, so it was great as far as glass cockpit technology. Very large screens, the Aviation system. He had some Garmin 530 and 430 on the airplane as well. He had onboard weather. And so this airplane was well equipped to fly this type of mission. And the pilot was given a great pictorial on all of the equipment in the airplane to show where the weather was and of course, the routes that he could deviate around that particular weather. As he was getting a transition to Memphis Center, he had started to enter into some weather. He told the air traffic controller that he was still deviating around, quote, little bumps and things like that. So from just that kind of description, it didn't sound like it was much. But when you start looking at the NEXRAD radar that we looked at that was pulled down, you could see that as he was making that deviation, he was flying in the area of some pretty significant weather conditions. And as he was transitioning through a particular area, he then reported after he came through this area to air traffic control that he was making an emergency descent because he had an engine problem. He didn't specify what type of engine problem. He just said he had an engine problem. And this is after he had transitioned through the bulk of this convective activity. And Todd's going to bring up a pictorial of the weather conditions and the radar track so that you at home can see what we're talking about. But as the pilot had transitioned out of this area, he reports an engine problem. He says that he's making an emergency descent. Of course, the air traffic controllers clear him, and they give him information about the nearest airport being at his 12 o'clock position in 5 miles. That's great as far as, okay, air traffic control is plugged in. This pilot is given voluntarily some information about apparently a suitable airport that he can go to. And in fact, the pilot accepts the information and says, that's the one we're gonna go after. We're gonna circle down to that particular airport. As he is transitioning out of 21,000 feet, and he has told him that he's got an engine problem, the controllers then say, okay, now this airport's at 7 miles at your 12 o'clock position. The pilot has been cleared down through 14,500 feet. Again, he's talking to air traffic control. It's apparent that he has the airplane under control. And as he's transitioning through 14,000 feet, he then tells the controller, yeah, because the controller queried whether this was an actual failure, shutdown, what was going on. He said, now we got a rough running engine. Those were his words, rough running engine. As the airplane continued to descend, he then finally told the controller, I'm shutting down the right engine. So now we know that this isn't a failure, but in fact, a voluntary shutdown of presumably the rough running engine being the right engine. So this isn't one of those startle or surprise where you have an immediate engine failure. The pilot knowingly, he had a rough running engine. He did apparently the prudent thing, and that was he shut the engine, the right engine down. He secured it, feathered the prop, and was continuing his descent towards the airport that he was choosing to land at. As he was circling down, according to the radar data, as he got near the airport, he was still pretty high, about 2.5 to 3 miles from the airport. He was about 5,300 feet. The airport that he was going into Alabama, has a field elevation of 113 feet. So he still had quite a bit of altitude to lose. Instead of apparently doing one more spiral down or circle down, he then started to head on a modified downwind base towards the airport. And then he flew past one of the runways. The runways at the airport are oriented east and west, basically runway 4 and 22. He flies through or beyond the center line for runway 4 and apparently looks to be entering a modified downwind, left downwind for runway 4. He'd flown through runway 22. So he was on a modified downwind for runway 4. And now he's heavy. He's got 7 people on board. They've got baggage on board, and he apparently had full fuel when he departed. So the airplane's heavy. He's flying what appears to be a traffic pattern, a downwind leg of a traffic pattern, and then makes a base turn. Now, he didn't do it in the immediate area of the airport itself. He was well away from the runway. So you're going to see a graphic. Todd's going to lay in a graphic as well for this particular airport, the radar tracks of the airplane. And then I've overlaid a couple of a yellow and a red line that would depict a normal type traffic pattern in its relation to the particular runway. And you'll see from the radar data that the airplane is well outside of that and flies away from the airport. And as the pilot makes this transition from a bit of a downwind to a base, he makes the base turn, but again, flies through center line for runway 4. And the airplane, you can see by the radar data and of course his ground speed that the airplane gets slow. And eventually the airplane got to a point where we believe it went into a VMC stall. And again, it's either a steep spiral or a spin. The airplane hit the ground in an area of trees, inverted, and there was a significant post-crash fire. And unfortunately, all 7 folks perished on board. When you look at the history, and the board has cited it in their report, they gave some background on the pilot. This pilot had about 1,000 hours of total time, was multi-engine rated. He had about 300 plus hours in this particular airplane, this model airplane. But again, you know, experience doesn't necessarily mean that you have experience. And that is just because we accumulate hours, and it sounds like 350 hours in this make and model is a lot. We in aviation, of course, use hours of flight time as our baseline for quote experience, unlike using years as service if you're in a job for 20 years or whatever. But just because you got 1,000 hours of total time and 300 plus in this particular make and model doesn't necessarily mean you have, quote, a lot of experience. because we don't know all the other types of flying this pilot may have been doing and how long he had been doing it as far as, years of accumulation of flight time. Nonetheless, you have a situation where you had a pilot who had a perfect opportunity from 21,000 feet. He does experience a problem. He voluntarily shuts down the engine. And unlike what the NTSB said in their report, where they called it an engine failure, and John, you and I have had these discussions where words have meanings, and you can change the meaning or the context of a whole discussion by your choice of words. This was not an engine failure. The pilot never reported a failure. The pilot reported a rough running engine. And then the pilot reported that he was shutting down the engine. That's a voluntary action. That is not an uncontrolled action that the pilot has to deal with. And again, when we talk about human factors and we talk about pilot mentality, unlike a failure where you have a surprise to a startle effect of, the engine just quit for unknown reasons, you're flying along fat, dumb, and happy, and boom, you just lost that engine. Now, all of a sudden, you're going through a methodical procedure versus, okay, I've got the airplane under control. Yeah, the engine's running rough. I can't seem to fix whatever it is that's causing it to run rough. I am now going to shut it down. I'm going to secure it and feather it. Those are two different types of mentalities. This was a known function by the pilot to shut that engine down. He has the airplane under control for better than 10 minutes as he's circling down towards this airport that he is intending to land at. The weather at the airport is good. It's VFR. The wind is at 270. Well, the closest reporting was 35 miles away, but the wind there was reported at 270 at 6 knots. So again, it's not like the wind is howling and you have to pick a specific runway. He could have landed on either runway, either 4 or 22. And even if it was a slight tailwind, you got better than 5,000 feet of runway at this particular airport. That in a quote emergency situation where you're flying single engine and you got a heavy airplane, you're going to want to put that airplane down on a piece of pavement sooner rather than later, rather than maneuvering all over the sky, heavy, low, and slow. Unfortunately, that wasn't the case. And so when the NTSB did its investigation, they get into the pilot's background, they get into some of the history of this airplane. And yeah, this was not the most stellar of aircraft. There were, it was a maintenance pig. There were a lot of issues, but the pilot had taken care of most of them, but not all of them. And in fact, he was actually trying to sell this airplane, and a pre-buy inspection showed that there were better than 70 discrepancies with this airplane. Now, this is a whole different line of discussion, because if you are a pilot operator, and again, we've talked about these things in the past and the responsibility of an owner operator, pilot operator of an airplane, if you know that you got a lot of problems with this airplane, some of which were airworthiness issues, where in fact the airplane may not have been airworthy and should not have been flown, now you're putting your family on an airplane that isn't in stellar condition. But this pilot chose to do it. He takes off, he flies, he's flying just fine, but then has this engine issue, rough running engine. Doesn't specify what he thinks it may be. He just says it's rough running and then decides to shut it down. So of course we had to pursue were any of these maintenance discrepancies or these airworthiness discrepancies attributable to causing maybe that rough running engine. All the things that were with that airplane, yes, you could kind of allude to possibly causing a rough running engine. The NTSB talked about them in generalities, but never really targeted any of these specific issues to the operation of that particular engine. But they did in their analysis of engine components, that is the crankshaft and camshaft in this particular engine, that they did find that there was a metallurgical issue with the gear teeth on the camshaft. And they concluded, based on their metallurgical work, that a couple of teeth on the camshaft gear had failed due to fatigue. And that was the basis for part of their eventual probable cause, which was a very simplistic probable cause. And it was of concern because when you read the report and you see all the information in the report, it's great that all of this information is in there, but it looks like filler more than actual substance that's related to the probable cause. And when you read this probable cause, and the probable cause is as follows: the National Transportation Safety Board determines the probable cause of this accident as follows: the pilot's failure to maintain airplane control during a single engine approach and his failure to fly an appropriate traffic pattern for a single engine landing. Contributing to the accident was a total loss of engine power on the right engine due to a fatigue failure of the right engine cam gear. Now, if we just break that apart and dissect that, yes, the pilot's failure to maintain airplane control, that's obvious. I mean, the airplane was out of control when it hit the ground, and it was during, of course, a single engine approach. The board has also said, and his failure to fly an appropriate traffic pattern for a single engine landing. Now, they don't specify what they think should have been the appropriate traffic pattern, whether it's just that he overshot final for runway 4 or that he should have used runway 22. It's a very generic vanilla statement that he didn't fly an appropriate traffic pattern. My big concern is contributing to the accident was a total loss of engine power. No, it wasn't. Not in any way, shape, or form. It was a rough running engine that the pilot voluntarily shut down. Did it, quote, result in a total loss of engine power? Yeah, because he shut the engine down. But the mechanical issue that they cite, which is the fatigue failure of the right engine cam gear, did not cause in any way, shape, or form a total loss of engine power. The pilot shut the engine down because it was running rough. So that in and of itself is inaccurate. And again, we've talked about words have meaning. It takes things out of context. But when you see a very vanilla probable cause like that, you got to question, okay, so where in this particular engine issue or the investigation of this accident, where are the lessons learned and where are the enhancements to aviation safety? And
Greg, I want to snap you back to the approach. You know, somewhere 14, 15,000 feet when he shut this engine down. You said that was the prudent thing to do. All right. What do you think would have happened if he kept that engine running? Because it was producing power. It was running rough. And, you know, to my way of thinking, until that engine is causing me, you know, a negative, even though it's not a full positive, I would have kept that thing running.
And you bring up a good point, John, and that is, of course, we don't know the extent of, quote, rough running. I mean, if it was shaking and vibrating the airplane so that the pilot's teeth were chattering or he couldn't see the instruments, that's one thing, because yes, you are gonna want to shut it down to get rid of that. If it's running rough and producing, you know, we don't know what incremental power, because there's that crossover point where even if the engine is still running and it's running rough, it's creating more drag than thrust. So we don't know any of those details. This airplane does not have a cockpit voice recorder, does not have a flight data recorder on it. So we don't know the extent of, quote, rough running. But it's apparent to the pilot that whatever was going on, he felt the need that he should shut it down, secure it, feather the prop, and continue flying, which he did, and he did it successfully on one engine to the airport.
And another thing that struck me reading through this, although that one airport was very close to where he was, there are other airports in the area. And at 21,000 feet, the glide ratio of this particular model of Cessna. I'm not sure exactly what it is, but it's something where if you're at 20,000 feet up, which is roughly 4 miles, you might be able to glide 10 or 15 miles, even if you had no power whatsoever. And if you had partial power, just one engine, you could either maintain an altitude at a lower altitude or at least have a glide ratio that's much, much better than when you had no engine. So it's not like he didn't have any choices. He chose
Correct.
this particular airport for whatever reason.
Correct. And while this was a suitable airport, it was 5,000 feet and 5,002 feet or something to that effect. It was a concrete runway. It was very suitable, a perfect general aviation type airport. There was a naval air station 35 miles away. And like you said, Todd, from 21,000 feet, if I'm given a couple of options and you got a naval air station, you got an quote emergency situation, that airport had a 8,000 foot runway. It definitely had any kind of emergency response that you could ask for if you thought that there was going to be some sort of problem once you got the airplane on the ground. So the pilot did have choices, but I'm not going to be critical of the fact that he went to an appropriate general aviation airport. He did circle down from 21,000 feet. He was in close proximity to this particular airport. It was the latter stages of the flight where he got himself in trouble. You have a fully loaded airplane with baggage and fuel. You know he's heavy, single engine performance, heavy, low, and slow, especially when you start configuring, because you know you're going to have to configure the airplane with flaps and gear. You better be in real close proximity to where you want to put that airplane down. You don't want to be flying B-52 type patterns where you're going away from your intended point of landing. You want to be able to maneuver the airplane with sufficient distance from the airport to make gradual turns. I can understand that, yes, this pilot may have gone beyond the center line for landing on runway 22 and decided to enter a conventional left downwind because he would be turning into the good engine since it was the right engine that he shut down. All of these are factors. Unfortunately, this pilot isn't alive to be able to interview and talk to and find out what his decision-making process was. We could only assume. But even if that was the methodology that he intended to use, if he had come out of his descending circle and then basically entered a modified base and then turned final for runway 22, he would have been making left turns. He would have still been turning into the good engine, configure the airplane, gear down, flaps down, and land. And even though the wind, if that same wind condition existed at the airport at the time that was reported 35 miles away, 270 at 6, landing on runway 22, 6 knots of wind wasn't going to matter because he had 5,000 feet of runway.
Another thing about this situation, there was an issue with the engine. He shut the engine down and was doing a one engine flight toward landing. He may have had a required number of practice one engine approaches, which is all very fine and good. But my understanding is that in rare cases, you're going to have a practice that's something other than maybe the pilot alone or the pilot and an instructor. In this case, the aircraft had 7 people total on board, and one would presume some luggage. This aircraft might have been close to max gross weight. I'm not sure, and there is nothing in the report that says so, that this pilot ever practiced this kind of one-engine flight with a heavily loaded aircraft.
And again, you bring up a very good point, and that is, yes, we don't normally do any kind of flight training unless maybe you're in a simulator, but there are very few simulators for Cessna 421s. It's usually training in the aircraft, and from what we understand, that's where he was doing his training. You aren't going to load at max gross. You, like you said, you're going to have gas, you're going to have yourself and an instructor, and the airplane's going to act a whole lot different when it's light versus when you got 7 people baggage and you know, almost a full bag of gas, because they had been flying for almost 2 hours before the accident occurred. So they were able to burn off some gas. Again, it's hard to know exactly what the weight and balance was as far as the center of gravity. If you have an aft center of gravity, that could have changed the way the pilot had to fly the airplane, especially when you start reconfiguring the airplane. And so all of these things factor in. Unfortunately, with the intensity of the post-crash fire, it's hard to determine exactly where things were loaded. I've done other accidents, similar 421, 414 accidents, where airplanes have crashed. They were aft loaded, so they had an aft CG, and with a single engine, they ended up losing the airplane because of controllability issues. That could or could not have played into it. But again, when you start looking at the operation and where the pilot flew this airplane to and eventually crashed versus the opportunity that he had coming out of that descending spiral from 21,000 feet in a perfect position to just manage the energy that he had in the airplane, even if it meant dropping approach flaps when the airplane was 2 miles out to lose that additional altitude. He was still at around 5,300 feet. He could have dropped that altitude very easily, managing his energy, using the appropriate flap configuration. And then as he positioned the airplane on this modified base to final, then reconfiguring for when the runway was made, gear down, and whatever remaining flaps he believed was necessary to put that airplane down on the runway. You didn't have to fly these big extended patterns like the radar data shows that he did.
And another issue that reading through this, and the tragic nature of the fact that you had an entire family in here, is that it's unclear to me and unclear from the report what kind of emotional management was going on at that time. You have 7 people inside the aircraft, one of whom is a pilot, single pilot operation. We didn't have any kind of personal electronic devices recording what was going on. Maybe things were very calm, and he'd practiced this with the people on board ahead of time, saying, hey, if things are going poorly, I'm going to be flying the airplane and you have to manage yourself. We don't know what was going on. We don't know if there was at least one other adult in the aircraft. We don't know if there was a de facto cockpit resource management situation going on, where the non-flying person in the front of the aircraft is handling things in the back of the aircraft while the pilot flies. We just don't know. But for the benefit of those who are watching now, if you're going to be in this kind of situation, do you think of it ahead of time? Not just the weight of flying with a full or nearly full aircraft, but are you going to brief the people on board the aircraft? Are the people on board the aircraft mature enough to understand what it is their responsibilities being passengers or being a front seater not flying in the aircraft? Again, these are all things that come to mind looking at this. Not necessarily part of the NTSB's job to analyze this, but if you're out there flying, this is something to think about.
Oh, absolutely, Todd. And again, we don't know, just because of the nature of the accident sequence or the impact sequence and the fact of who was where and the intensity of the post-accident fire. But assuming that, yes, you have this pilot, he's operating single pilot. So with an engine out, he's already into his maximum task and single engine activities. Now you throw in the fact that in the back of his mind, he's got his family on board, but he still has to manage flying this airplane safely. We don't know if there's any distractions. There were 5 young kids on board, and so we don't know how they're being managed. His wife was on board. We don't know if she's up front or back with the kids or who's sitting in the right front seat. But the fact is that pilots who fly their families like this, or even just passengers who don't fly on general aviation airplanes much, especially in a high stress, high anxiety situation like this, even though it appeared to be under control throughout the majority of the flight, so there was no real sense of alarm, we don't know what's going on. A lot of people have surmised that when JFK Jr. with his wife and sister-in-law were on that airplane and things started to go bad, that there's been all sorts of internet discussion that, oh my God, these 2 women are screaming bloody murder, and JFK Jr. not being very experienced is trying to manage that and fly the airplane and that kind of thing. Yes, you can put these fantasies and build them into the equation, but again, as pilots, we have a responsibility 91.3 says we have that responsibility as the pilot in command to do whatever it takes to be a pilot. That is to command that aircraft. And yes, we do have to filter out those distractions. Yes, your primary responsibility is to fly that airplane, lock, stock, and barrel. Yes, there's going to be a lot of stuff going on, but your primary responsibility is to fly that aircraft. In single pilot operations, especially in complex situations like an engine out, heavy, low, and slow like this, it can be task saturated. I mean, you're trying to read a checklist. You're preparing to put this airplane down. You got to reconfigure. You got to fly. You got to make sure everything is good to go. You're trying to do all of those things, and there are cases where you just get over your head with that kind of situation. And the takeaway from this discussion is that you have to be prepared 5 miles out, 10 miles out. This guy's coming out of altitude from 21,000 feet. You got a long time. Yeah, you got the airplane under control. Things are going fine. You're doing your thing to get to the airport. This is the time to really do that preparation. Okay, once I get down to where I need to be, how am I going to fly this traffic pattern? Why he flew the traffic pattern or the quasi-traffic pattern that he did, no one will ever know. But that's all part of planning ahead. You cannot wait to plan on the fly, pardon the pun, as you're moving or progressing in this particular situation. But pilot distractions and, of course, briefing people. Okay, hey, we got everything under control. There's no reason for alarm. Okay, be prepared. Yeah, the landing could be a little rough because we're flying single engine. The airplane isn't flying as it should be. So yeah, you might feel a big bounce, or hell, we might even hit too hard and collapse the gear. Be prepared, but don't be worried. We don't know if that's going on.
That all gets to what I've been hopping on at the end of every show about planning your flight. It's not just planning the takeoff, it's planning the whole adventure and all the contingencies in the middle. And all too often we see in accidents that doesn't happen. Greg, I mentioned to you the other day, but I haven't followed up with you in the conversation, but I've made arrangements to have on a doctor, a PhD kind of doctor that has been dealing with aviation decision-making for years. And I know that we also have one out in Denver, happens to be your office partner. And I want to get into this whole area of decision-making, not only for pilots, but for dispatchers and mechanics as well. Yeah. Because, all of those elements fit into flight like a hand in a glove, and they have to interface with one another, and they all have to make decisions along the way. So I want to start an ongoing session of our podcast dealing with those different elements and different work groups with decision-making. So we're going to start that pretty soon. But this accident clearly has a number of so-called forks in the road for the pilot to make decisions. Like I mentioned just a few minutes ago about the decision to shut the engine down. And Todd mentioned earlier, or you did, about the decision to take this airport or go to a bigger airport where there was suitable crash fire rescue, and also most likely a hospital on board in case things didn't turn out well. So all of those decisions that as airmen, whether you're a pilot, mechanic, or whoever you are in the operation, all those decisions are critical. And in my speeches and presentations that I give, I often tell people that there's no job in aviation that's unimportant. We oftentimes have airplanes misfueled. The line boy, which I was one many, many, many years ago, right? Fueling airplanes, wrong fuel installed. I mean, these guys are among the lowest paid in the business, and they have a lot of responsibility. And I see pilots oftentimes not even double checking the work of these people as we're supposed to. So all those decision makings we need to get into and talk to our.
But again, in a lot of the decision making that's going on, you're doing it under high stress, high anxiety situation. You're single pilot. You have no alternative. You can't workload shed to someone else. I mean, it could have happened. I mean, we don't know, again, where this pilot's wife was. She could have been running a checklist or reading the checklist for him and things like that. We just don't know. But presuming that wasn't taking place because she's in the back with the kids and everything else, now the pilot is left to his own devices. That is, he's got to read checklists, got to perform the actions, got to talk to air traffic control, got to manage the state of the airplane, and then in possibly some cases, manage the passengers. That's a lot going on in very short periods of time. Plus, you're trying to pre-plan as you're flying along. You're trying to figure out what you're doing, where you're going. And if you don't have that plan, John, like you talked about, then you're doing things, taking in new pieces of information, and then trying to analyze it while you're doing all these other things. And usually the decisions that you make are not good decisions for whatever reason. We see it a lot in accident investigation. But the big problem here, John, is that while, yes, there were a lot of mechanical discrepancies with this airplane, and in fact, this airplane probably should have not been in the air because of some of them, you have to ferret out whether or not they caused or contributed to the accident. Of course, the NTSB tears down this engine that was shut down, and they find these gear teeth coming or off the cam gear. Okay, that's great. But again, what came of that? Okay, why did they come off? They didn't tell me why they came off other than it was fatigue. Well, is it because it should have been changed out? Was there corrosion pitting? Was there, was this thing an old camshaft and cam? What's the basis for these teeth just coming off? I mean, they don't just come off. Well, of course, after the NTSB comes up with their conclusion, there's always the next level of investigation involved in litigation. And when you start looking at some of the additional examination of this airplane and the engine, of course, this is where some really good information came out. And again, you talked about it at the beginning of this discussion. This is where the board should have taken this. They stopped at the obvious. Well, the two cam gears came off. They stopped at the obvious. It was continued investigation that they had information for. They had this information. They just choose, for whatever reason, not to go and explore it further. And of course, through the litigation process, one of the avenues to pursue is other mechanical issues with this engine that led to the failure of the gear. And those mechanical issues were explored, but it really came back to further metallurgical study of these cam gears and the surrounding evidence of where those gear teeth failed. And as we found out in subsequent investigation, which was again readily available and visible to the NTSB and their metallurgists, we found areas of molten metal where those teeth had failed. And when you start looking at the area and the high temperature that would have caused molten metal, you wouldn't see those types of temperatures during any kind of normal or even abnormal operation that could have caused isolated high level temperatures to cause failures of those cam gear teeth. That's where, again, you got to take it to the next level. So now you got to start looking at, okay, if it's an isolated area where you have an extreme high temperature, what would have caused that extreme high temperature in a very specific isolated area? And that's where our investigation, the one that I was involved with, took us. And the finding was 180 degrees out of phase with what the NTSB found. Yes, those gear teeth did in fact fail, but the failure mode, which the board doesn't talk about other than fatigue, was due to something external to the aircraft, which then had an adverse effect internally to this engine.
You know, Greg, for years before I came to the board, and then while I was at the board, I can't tell you how many strong discussions I had with the management in the Aviation Accident Investigation Bureau, people you worked for, about stopping the investigation at the hangar doors. more than once, it was maintenance, take it up to the hangar door and stop right there and say it was a maintenance issue. And as a result of doing that, we never got the data that could have driven changes within the maintenance department. Instead, we just continued on the way we were doing things forever and then wait for the next event. And we saw them over and over and over again. You know, it took a long time to change inspection procedures. And it was only until Sioux City, Iowa with United, when all of a sudden we discovered that fluorescent penetrant inspection for critical rotating components was inadequate. Although I know a lot of people internal to the airlines, not just the one I worked for, had been saying that for a while and receiving no traction within the industry to correct that. And they could have used the help from the NTSB from the previous events to change it. And I actually was the hearing officer for the hearing on a JT8D that went boom in Pensacola and killed a few people. And in that case, it was fluorescent penetrant inspection. And that was finally the move to get the industry, not just an individual airline, but to get the industry to start looking at the appropriateness of FPI on some of these critical engine components.
Yeah.
But how many years did we waste by not going into the hangar? And I think I know the reason, at least part of the reason, is because they never had any real mechanics that worked there. Well, yes, we had some people that had an A&P, they went to school, then they went to become pilots.
Yeah.
And they never really worked any length of time in the maintenance organizations to understand the system. And admittedly, I was very fortunate that I touched many different airlines because of the work that I was doing. If I started my career at United Airlines, if I stayed with United, I would not have had the view of what goes on in the industry that I had in the 90s when I went to the NTSB, because I had the opportunity to work with Delta, Northwest Airlines, Flying Tigers, the list goes on and on. I had the opportunity to look into the way they do things, and everybody does things, every airline does things a little bit differently. But the NTSB should have been in there doing the detail. And the thing that frustrated me when I was reading this report about the engine teardown is, you can sum up the engine teardown in one 6-letter word. It wasn't very good. It's just.
Yep, this is a family show, John. I'm glad you mentioned.
Well, that's why I didn't say my feelings. All right, but I don't think there's a mechanic worth of salt that would look at that, what they did on that teardown and say it was adequate.
Yep.
Right. So they just went over lightly. They saw what they needed. They probably tore the engine down, took those pieces out, sent them back to the lab, and didn't look any further.
Yep, exactly. And that's the concern, because our responsibility as investigators is to investigate. And I use those words at the beginning, and that is thorough and methodical. I use those words every day when I talk about acts investigation, thorough and methodical. Whether you fly it, fix it, or manage it, you have to be thorough and methodical. You have to look at how the pieces interconnect with each other. And you have to use logic, but you also have to be cautious of the words that you use and the context of those words, because in this case, with the NTSB's probable cause, it changes the entire meaning of the causal factors of the related engine problem. This was not an engine failure due to cam gear teeth fatigue failing. In fact, when we did the investigation and we examined the engine and the propeller and other parts of the aircraft, what we found was that the airplane had taken a lightning strike. You have to identify how high heat energy can be isolated in a specific point. And if you have a lightning strike on a key component of an engine where you're transmitting high energy that can create high heat, you're going to have issues. And in fact, we found the entrance and the exit points where this airplane took a lightning strike. And what you have to do is take corroborating evidence. Okay, You say it took a lightning strike. Let's go back and see the flight path of this airplane. Oh, by the way, when you see the flight path of the airplane, even though the pilot didn't say anything about seeing that he flew through a thunderstorm and he had a bright flash and he took a hit, and it's obvious that the electronics still worked for him to be able to communicate. We don't know. He never said anything about whether or not he lost any of his other electronics. He didn't give us a blow by blow. All he said was, I got a rough running engine after he transited through this thunderstorm. And when you look at the NEXRAD data that we've posted with this video, and you look at the flight path, and you look at the areas of lightning, and I know that, you know, yes, different airplanes take different lightning strikes. There's a boatload of pictures of commercial airliners taking lightning hits. I think there's a famous one with a 747 taking off, taking a lightning hit. I think there's a Delta 73 or 76 that's on the ground that takes a lightning hit at LaGuardia. Lightning doesn't choose where it's going to hit an airplane. It just hits the airplane. Sometimes it's in the front, sometimes it's in the back, sometimes it's in the middle. But the fact is that as investigators, and if you know the airplane had just transited through weather, and again, when you look at the NTSB report, they only talk about localized weather, what the weather was where this guy was trying to land. You have to look at the big picture. You have to go back.
Speaking specifically about the lightning striking the aircraft, something that you talked about before the show that I found fascinating was that even if you have a direct strike on an aircraft, even if you're in the aircraft, it may not be at all clear to you that you were hit by lightning. Now, you know, a little bit I know about lightning. For example, one of the characteristics that most people know about is thunder. Well, for thunder, you need to have some sort of shock wave going through the air. But if you have a close-in strike, you're not going to hear thunder. But it's, well, you can take it from here. What's the possible things they could have seen that might have not really clued the pilot in that they had a direct lightning strike?
Well, we've talked about this, Todd, and John and I were having a brief conversation. When you really examine lightning, a lot of times lightning is ground up. That is, it starts at the ground and goes to the clouds. Everybody always says that, well, it comes out of the clouds and goes to the ground. That's not necessarily true. And then, of course, you have cloud-to-cloud lightning. Lightning, you know, the static electrical charge is dissipating between the pluses and the minuses between two convective areas. Thunderstorms, and when you really dissect it, and John and I have a really good buddy of ours, Dr. Dave Straley. He is a PhD weather guru. And when you talk to him, thunderstorms transfer energy. So you could have two thunderstorms and you have a clear area, or what you think is a clear area between these two. That's a high energy, that's an alley. And we saw this in American 1420, where they were trying to shoot the bowling alley, you know, go right down the middle between two thunderstorms. What people don't know, and pilots, a lot of pilots don't know, is that thunderstorm or convective activity that has this gap transfers energy between the two. There's energy transfer all the time. You can have lightning jumping between that. You can have these thunderstorms coming together to merge. So there's a lot of energy. And when you look at the flight path of this 421 going through a line of convective activity, they get into some yellow on the NEXRAD, which is not a good place to be. There was a lot of energy in this convective activity, which then makes it prone for lightning. And the pilot, as he's flying through it or she's flying through it, if you got a lightning strike in the back of the airplane, you may not see anything. You may not see any indications in the airplane either. We have static wicks on the airplane to dissipate static electricity, diffuse lightning strikes and things like that. But if you take a hit from lightning in the front area of the airplane, you may see a bright flash. You may not see Thor's bolt of lightning actually strike the airplane. You could. If you're in IMC at the time, it could be a diffused flash. Even if the airplane is struck by lightning somewhere other than in the very front, you may see a diffused flash, but you may not see any readily visible results of all the avionics going out or something to that effect. So again, just because you don't necessarily see it doesn't mean it didn't happen. And in this case, when you start looking at the sequence of events, You got a pilot who says that he's dodging or at least deviating around these thunderstorms or little bumps, as he called them, and things like that. And he's transiting through an area that when you look at the next rad, you know that it's conducive for that kind of energy, especially to produce lightning. And then comes out the backside in 3 or 4 minutes after transiting this area, then reports, hey, I've got a rough running engine. Well, you know he had a rough running engine coming out of it. It's just that it took some time for him to assimilate what the heck's going on here. I've got a problem. And then he confesses that to ATC. Hey, I got a rough running engine. I'm making this emergency descent. So it happened probably 2 or 3 minutes before. He just got around to, again, making it a point of flying the airplane and then talking to air traffic control. Hey, I've got an issue. I've got to fix it. And the rest is history from there.
You know, as you're talking, Greg, I'm thinking about all the years I worked out in turning wrenches, and I can easily think of over 100 times where I found evidence of a lightning strike on an airplane that the pilot never knew. You know, oftentimes if I saw the static wicks, 1 or 2 of them burned off the airplane, go looking for the point where the lightning entered the airplane, and you'll often find it on forward of the wings, on the wing leading edges, and it exited the wing on the tail. Or you might find it that the vertical fin took the hit and the static wicks back on the tail were burned off. Very, very common. And I'm not the only one. I spoke to a friend of mine that works at JFK, where they have to do lightning strike inspections on the airplane before they go ETOPS to engines over the ocean, over the Atlantic. And they have a notable number of times where they've pulled the airplane out of service because they had evidence of a lightning strike that the pilots never knew they had. So that lightning strikes are not this great big obvious thing that people think of when they see the lightning hit the tree across the street. It can come into the airplane and go out, and nobody knows it. But there is some physical damage at the entrance point and where it leaves the airplane.
And John, when you see the damage on a GA aircraft, it's not necessarily some big blackened area. It could be something very tiny. How would you describe?
Tiny little pinholes.
Yeah, they're very small pinholes, little burned areas, and you really have to look. I've looked at a number. I looked at a jet not too long ago where we don't know where it came in, but we saw where it went out, and that was out at the wingtip right next to the strobe light. And because the airplane was involved in an accident, it could be easily overlooked. And so you're looking, and it was an area where the rest of the wingtip was intact, except for this little burn hole. And it's like, well, that's unusual because the rest of the wingtip was intact. And that's what caught my eye, was the fact that that shouldn't be there. Now you're thinking, okay, well, was there a short in the strobe? Because the strobes are high energy, isolated in a particular area. But where this particular little burn hole was not exposed in any way, shape, or form to any of the wiring or to the energy transmitted or at least produced by the strobe. It was adjacent to it some distance, but it was in an area that you wouldn't expect. And it's those kinds of things. And that's why you cannot just take things for granted. And you have to answer the question, what caused those 2 teeth on that cam gear to, quote, fatigue fail? They don't just fatigue fail. Something had to do it. Was it excessive vibration? Was it excessive heat, like in this case? Was it something else? Was there a improper meshing of the gears as they were coming through because something moved, something was vibrating? You have to answer those questions. You can't just write it off to, well, those 2 teeth failed and that's what caused it. There's always a reason, and the root cause is what caused that failure. Now, if that was a fatigue crack due to vibration, and there was some issue, whether it was internal to the engine, the motor mounts, lack of maintenance, it was an old cam shaft with a cam gear, that's where the root cause is. And then what's the safety benefit? Well, Maybe you got to put out a shorter inspection cycle because this thing had been in service too long, and this could happen to other airplanes. Those are the safety benefits. You read this report, there's not one safety benefit that came out of this NTSB report, not one. And even though this was a lightning strike as we saw it, and we were able to identify it and determine it, what's the safety benefit? You put out a safety alert like the NTSB is notoriously loving to do all the time, reminding pilots about the proper techniques of flying around thunderstorms, not being within 20 miles, talking about the fact that you have these energy states, and get their meteorologist to write something up about the effects of convective activity in flying general aviation airplanes through it or underneath it. Those are the safety benefits. Nothing came out of this report. And that's the thing that just galls me, because we as investigators and people that are purveyors of aviation safety should be putting that kind of stuff out. And that's not being done.
John and Greg, both of you have worked on literally hundreds of different NTSB investigations, from major investigations to things involving GA aircraft. My experience has been very limited. When I was with a manufacturer, I assisted indirectly on some major investigations, and I sort of got spoiled into thinking, oh, thorough investigations, there's going to be probable causes, maybe suggestions for safety improvements. And the assumption I had was that, hey, in the major investigations, you have a whole lot of eyes looking at this, maybe several people getting together to put together the probable cause, the conclusions, et cetera. So you might not have the issue of one person having, one way of thinking, and that ends up in the report. Looking at a report like this, it seems to me that a lot of the ones that are the shorter reports, GA aircraft, is it my mistake? You only have like one person doing this in most cases?
Yeah, usually one person. They've done the investigation, and then they have to run it through the system where other people will look at it, but they're looking at the material that one person put together.
Yeah, and again, yes, you have the investigator in charge from the NTSB who does field investigations. In this case, they had the subject matter expertise of somebody in their metallurgy department who did the metallurgical work, produced the report. And then, of course, you do have the manufacturers who are parties to the investigation. But again, everybody is following the lead of the NTSB investigator. And if this is the direction that they want to go, then everybody follows. And while suggestions can be made that, hey, maybe we should look at this and maybe we should look at that. And we see that all the time with major investigations where you have a lot of party players involved in the process, as well as subject matter experts from the board. On these general aviation type accidents, such as this one, you have one IIC. And of course, in this case, they use their metallurgist, but you have a party rep from the FAA, party rep from the manufacturer, Cessna, and Continental Motors. And if the board says, we're going this direction, then a lot of times, 90% of the time, that's the direction they're going, and nobody's really expanding the scope. And I'm not saying that, you can't do that, but you have got to put a logic to these conclusions, and you have to answer the question, well, what caused the fatigue failure of these two gear teeth, if that's the path you're going down? And it better be logical, it better be reasonable, and it better be supportable. And there is nothing in this report that supports why the fatigue happened.
Greg, I'm anxious to see what's going to happen post-COVID, pre the introduction of COVID. So a year and a half ago, when COVID started to shut down the country and the government shut down, the NTSB, we still had accidents, and they were not going out. The FAA was going to do an initial on-scene investigation, and then they scooped the rest up, the remains of whatever accident was there, and put it in the storage someplace.
Yeah.
And you and I both know that's going to have an impact on the outcome of the investigations. So it's going to be interesting to see on how the NTSB categorizes those 400 plus accidents that have occurred, and what impact that's going to have on safety in general, because we analyze, lots of us in industry analyze the reports looking for the nuggets to make improvements beyond what even was in the report. And now with the factual data being weak, if not missing, it's going to really impact upon those outcomes and what we can gain from those accidents to make improvements. I think we're really going to be paying the price for that for a couple of years to come,
and
at least.
And as painful as it is for me to say this, you know, you and I and Todd are going to have a lot of accidents to dissect where there's always the backstory. And it's going to be our backstory that is actually the root cause of these accidents. There's a lot of accidents I've been working, as you know, from last year, that the board will never have the information that we're able to get. Why? Because they didn't go out. Why? Because they didn't follow up. And trying to follow up a year or 2 years after the event, it's impossible. You can't talk to witnesses. Their stories change. They forget. They don't know. And you've lost all the good stuff. And now you go with a very generic vanilla cause. Pilot lost control for unknown reasons. You know, engine failed for unknown reasons. Those do not do the family any justice with regard to determining a cause or contributing factor. I'm looking at an accident right now where the NTSB came up with a vanilla probable cause on a guy who was an established and esteemed Black Hawk pilot in the military who ended up crashing a fixed wing airplane. And of course, the vanilla probable cause was, well, the pilot lost control in mountainous terrain, trying to turn around. When you start looking at the facts, conditions, circumstances, don't you think that a Black Hawk pilot who flies at altitude out here all the time, you know, he's pretty plugged into flying and density, altitude, and everything else. And then you have the NTSB going, well, you got a pilot who's flying a fixed wing airplane, didn't understand density, altitude, flew the airplane over a mountain and crashed. It does not make logical sense. And you have to look at all the facts, conditions, and circumstances. But they write this off to, you know, it's one of those easy probable causes, move on. Well, it's not that easy. And it's not, even if that was truly the case, which looking at the stuff that I'm looking at doesn't support that. But even if that was the case, that still is really not justifiable as far as, you know, being that kind of critical without a lot of information for the families. And again, there's a lot of accidents that happened over the last year and a half where if they come up with a vanilla probable cause and indict the pilot lost control for unknown reasons. Really? There are a lot of accidents and incidents out there. Every one of them has a reason. You just have to be an investigator and go find it. So, well, I've gotten on my soapbox, and I know that there's a lot to talk about with an accident like this. I think the takeaway from our discussion, and you guys be, you know, more than happy to chime in. Pilots have to be prepared. John, you preach it all the time at the end of our shows. You've got to think about the what ifs. You constantly have to think. That's what you get. That's why you have a pilot certificate in your pocket, because the FAA says, yeah, we're going to let you fly, but you got to think. You got to be a pilot. Even under the most dire of circumstances, you got to be a pilot. And yes, that escalates when you have your family on board. Why? Because you have your family on board and you constantly have those things in the back of your head. But in order to do the best you can do to heighten your chances of survival is to be prepared. Even when you're fat, dumb, and happy at 21,000 feet on autopilot, you've got to be running scenarios. I don't care if you fly that airplane every single day. You don't want to be caught by surprise. You want to have that plan. Okay, if I lose an engine, if I have to divert, if I have to descend for whatever reason, pick a scenario. Run it through your head, because if you have that mental model already up here, then when it happens, it is not a surprise and you're not trying to figure things out on the fly. You already have a pre-established plan. It may not be the exact plan, but at least you have the framework for a plan. And it's better to have a plan, even if it's not complete, than to not have anything at all. So that's the takeaway, because the lightning strike and the engine shutdown didn't cause this accident. And I preach it all the time. Unless the engine blows up off the airplane, whether it's out on a wing or off the front end of a single engine airplane or a jet in the back, unless that engine blows up and leaves the airplane to change the entire center of gravity and cause the airplane to be so unstable you can't fly the airplane, engine failures, engine shutdowns do not cause accidents. It is the resulting operation by the pilot that ends up in damaging the airplane or inflicting the injuries. Why? The airplane was still flying. And in this case, that airplane was still flyable. It was flyable all the way down to a successful landing. But for the fact that the pilot did what he did and flew this B-52 pattern and flew it in such a manner so as to lose control because he got below VMC, that's on him. That's not on the airplane. The airplane was capable of flying. He made it all the way to the airport. He could have landed. So it's all about pilot preparation, pilot pre-planning, thinking continuously, what if, while you're running those, while you're in flight. Maintenance, of course, yes, there were some maintenance issues that should have been addressed. While they didn't have a direct bearing on the cause of this accident, it is obvious that, again, the onus is on the pilot, owner, operator, that if you have an airplane that is borderline or has a lot of maintenance issues, and some in this case were something that should have downed that airplane and made it unairworthy. And this guy consciously chose to put his family on an airplane that was suspect. That too needs to be factored in. These are the kinds of things that the lessons learned. You have to err on the side of safety. And that little voice in your head going, should I or shouldn't I? Should I or shouldn't I? And it says you shouldn't. You don't discount that. Why? Because that's gut. And your gut says, I shouldn't do this today. I shouldn't fly on a day like today because the weather's too bad. I shouldn't fly on a day like today because the airplane really isn't where I think it needs to be. You have to listen to that voice, because it's not only you that's going to be compromised. And in this case, you wiped out basically an entire family. There was one survivor. It was a daughter who never got on the airplane. And it's a tragedy.
I had a pilot, a commercial pilot, in a discussion one day, and we were talking about flying commercially or flying recreationally. And he made a statement that I never forgot. He said, when you're the pilot flying the airplane, you never fly recreationally. You're always the pilot. You're always at work. You have responsibilities that you can't neglect, right? And too many people I see to go fly for an hour and a half a day at the FBO where I work. They're going out to have a good time. They're not mentally, they're not prepared to spend however long they're in the air to be focused on flying.
Yep.
They're going out, they're taking one or two of their friends with them, and they're gonna have a good time flying, but you can't give up control of the airplane to have a good time. As a pilot, you have a big burden, and that's the safety.
That's why it's called pilot in command. Act as a pilot in command. You're not in command when that airplane does something that you didn't command it to do. And again, you never want that to happen. That's why you are the PIC. And with that professional attitude that you're talking about, John, people go, you know what? I'm just going around the patch. I don't need to have a professional attitude. Yes, you do. Why? Because if you shortcut, you don't use a checklist, you're trying to, quote, do those things, you're trying to do the right thing even when nobody's looking. That's what it's all about. You do the right thing even when nobody's looking. But too often the mentality is nobody's looking, therefore I don't really have to use a checklist. I've flown this airplane so many times, I know it off the top of my head. Not in a high stress, high anxiety situation. You're flying downwind and you're not using the checklist because you already anticipate that you're going to make that base to final turn. You're starting to configure the 172. What's the big deal? It's not a complex airplane. And oh, by the way, as you transition and underneath you, there is, housing developments, and there's stores and restaurants and everything else. And oh, by the way, the engine quits. And oh, by the way, you've already started to descend and you don't have enough energy to make it to the airport. Where are you going?
Yeah, I just watched one within the last 10 days, landing at an airport, pretty good size airport, single runway, I forget now, 5,000 or 6,000 feet long. And he's doing a circle approach. And I watched him come around with the circle approach, and I was sort of started to pay attention because I was driving with the airport to my left, and I'm saying, geez, he's awful close. Well, he finished the circle approach, and when he approached the center line of the airplane, diving down for the runway.
Yeah.
And I mean, he was coming down at a pretty steep angle to make his landing, and he made it. But A, it was very, very risky, and B, I wonder how many times he's done that before that he was able to do it so smoothly.
Yeah.
I mean, that's risky business right there.
And one thing I want to ask to add to this, the audience might think, well, we're tearing apart this report, and these reports are, horrible to look at because they're not, well, these are learning opportunities for you as a pilot. These are learning opportunities if you're in the industry and you're going to look at these accident incident reports to get some insights, to ask your own questions. If you come across something like this on your own and you say to yourself, well, why didn't they do this? Why didn't they take this step? That's good.
Yeah.
You're engaging yourself in it. And maybe when you come across a report, especially of not a major accident report, but a GA report of something that's relevant to what you do, and you think it's well written, you think it's thorough, you think it's logical, you think, man, this is the way it's done. This is something I can learn from. That too is good.
Absolutely. And you bring up a good point as we end this show, Todd, and that is, John and I have talked about it. That's the premise of this show. There is always a backstory, and in asking those questions or coming up with, the questions that you just brought up, when we have viewers who are reading reports and they go, well, why didn't they do this? We do the same thing. Accidents, every accident I read, I start reading through it. And yes, some of them are good. Some of them are very good. And then there are others where it's just like, there's 6,000 other questions that they didn't answer. And how did they support a probable cause of this when there's no facts to support it? It looks like they reverse engineered it. They came up with the reason or the cause and then tried to cherry pick some facts to support it. That just does not work for a multiple of reasons. But one, and the primary one, is how does this accident investigation enhance aviation safety? And in this case, there is no enhancement to aviation safety. They came up with a generic vanilla probable cause and moved on. There are learning lessons in this particular accident. We went through just a handful of them in the hour plus we've been talking about it. But I could rip this apart even further, which I did. And there are other things. And when you really systematically look at it, that's the way you enhance aviation safety. Because if you understand the context and you look at the details, because it's always the details that enhance safety. This is just very generic. And in the next accident that we dissect, which we're going to do, it'll be another multi-engine general aviation airplane. It has a whole different set of circumstances, but there is a lot of learning opportunity in that particular accident as well. So John, with that, getting off my high horse, I'm going to let you close us out with our sponsors, and of course, leaving you with the last words.
Well, the last word we've been talking about for the last half hour. But in any event, I want to remind everybody that today's show has been brought to you by PAMA, the Professional Aviation Maintenance Association, PAMA.org, if you want to take a look at their website, and by Avemco Insurance. And to my way of thinking, they are the premier general aviation insurance company out there. And they have a number of advantages for the GA community, one of which is when you call them, you are talking to the insurance company. You're not talking to a broker. You're talking to the people who make decisions on if you have a problem on your problem. And if you need insurance, whether you've got a house insurance or if you're a flight instructor that needs insurance, or if you're a renter, which is a very important piece today, have insurance for flying someone else's airplane, give them a call, mention the show, you get a 5% discount. And I can tell you firsthand, they're nice people to deal with. They're very down to earth, very forthcoming. They're open and honest with you, so you can't go wrong. Even if you don't choose them, call them, because they're going to open your eyes to some of the questions you might want to ask if you're going elsewhere to another insurance company.
Hey, John, I'm going to interrupt you because you got me so excited with this with particular discussion that I forgot to mention that we get a lot of emails, and we appreciate our viewers and our listeners giving us their feedback, good, bad, and indifferent. John and I are actually probably talk about a lot of that on the next show. We've had a lot of suggestions, not only for shows, but some of the feedback on some of the shows we've done and that kind of thing. But you can always get a hold of John or I or Todd through our email at flightsafetydetectives@gmail.com. We look at every one of them. Again, we start to collate this. We've gotten some great feedback. People really like this. One of our last shows where we talked about service bulletins, that's what we want to hear. We want to know that you've learned something from it. Like these accident dissections and everything else. Tell us what you like, what you don't like. If you think we're full of it, great, tell us. But again, if you're going to tell us that you don't know what you're talking about, great. You better have some good factual information, because that's the world we deal in, and we'll take you on and we'll have a great spirited debate, good, bad, or indifferent. That'll be perfect. Why? Because it's another learning opportunity. So please reach out to us via our email. Definitely watch us on YouTube or through the podcast, and please give us a positive rating. Tell us your friend, or tell this show about to your friends, because we want to increase the productivity of this show. We want to make this show better. And the way we do that is better ratings, more people watching, more subscribers, so that we can take this show continually to the next level. So John, now I'm going to give you the last word.
And I want to add to that, though, but you know what? The more people, the more pilots in particular that we have that listen to us, the more opportunity we have to prevent an accident in the future.
Yeah.
If they listen to us and pick up one clue, like that one airline captain did on my preaching pre-flights, and how he talked about what suddenly he changes his pre-flights and what he has found, where he normally just walked around and relied upon other people, mainly the maintenance people, which don't exist in every station. But in any event, the more pilots we can reach, the more they can recognize what we're saying, and the little light bulb in their head goes on, so it gets better. But to all of our pilots out there, especially the GA pilots, if you're going to go flying, do a good session of pre-planning. We said today, it's not just what's going to happen on takeoff. You need to know an alternative if you lose engine on takeoff. You need to pre-plan for en route, especially today with so many of our airplanes having long legs, so to speak. You're going to fly for 2 or 3 hours nonstop. Well, that's a lot of distance. You need to know where it is. Fortunately today with the modern avionics, it'll identify the airports below you, right? But when I learned to fly, you had to know where they were. So when you did pre-planning, you looked at your route and looked around for airports as way markers, so to speak. So you knew where you were. Right? So do a very thorough pre-planning. Do an excellent pre-flight. And if you need any guidance on your pre-flight, get your mechanic to walk around with you. I like to touch the airplane when I go around. I like to touch the wing, wiggle the wing, and we actually had an airplane that was wiggled by the pilot, and his wing moved in a different way than it moved previously. And he ended up with a spar problem.
Yep.
And so he identified it going off, something he never would have seen. Right? A good pre-flight, talk to your mechanic. He can help you through them. And if your airplane comes out of maintenance, then really do an exceptional pre-flight. Right? And if you get through all of that and you go flying, please pay attention from beginning to end and fly safely.